Welcome to Hartman Math. This is lesson 5.7, Simplifying Radicals, Part 2. So example number 1, we're going to do a square root. 99x is 6. So there's a couple parts to this. We've got a numerical part, the constant part, multiplied by some sort of variable expression as well. So first thing we kind of need to know for a problem like this is what is the index? Which root are we taking? And it's not written in here, but we do know square root means a second root. So our index is a 2. We're going to see where that comes in. So we've got experience simplifying the square root of 99 where we just break it up. And we're going to do that type of thing for the numerical part. We're going to do something else for the variable part. So we're going to break up the 99. We're looking for 9 times 11. As we break it up, root 9, root 11. And we know what the square root of 9 is. So as far as we start writing our answer, it's a 3. This we can't do, so that's going to stay inside the root. We're going to continue along and see if there's anything else that comes outside of the root with that 3, since we were able to take the square root of 9. So the way that we do this with the exponent part, take the index and divide it into the exponent. 2 goes into 6 3 times, so out comes x to the third power. So square root of 9, and then 2 goes into 6 3 times, so x to the third. Now we have our leftovers. Couldn't do anything with this. We're talking about square root of 11. Example number 2, cube root of. So we're going to take a similar approach. We want to be breaking down the 24, looking for perfect cubes, like 8. 8 and 3 on the breaking it up. All right, now, so we're going to look as what is the cube root of 8? So we'll start by writing 2. And then we'll look in the x's. 3 goes into 8. How many times? Now it doesn't go in evenly. But how many times does 3 go into 8? Twice. So out comes x squared. 3 goes into 12 4 times. So out comes y to the fourth power. And then we get our leftovers. So the 3 is left over. Don't forget the index. It's a very common problem to write the radical sign but not write the index. So if you don't write the index, you automatically assume that you're talking about square root, which is not the case here. We're talking about a cube root. So cube root of 3. Now let's go back to, remember when we divided the 3 into the 8 for the x's, it didn't go in evenly. So what was the remainder? 3 goes into 8 twice with the remainder of 2. We're going to kind of show that. So 3 goes into 8 twice. And there we go, a remainder of 2. So that means that x to the second power is also going to stay behind and in the root as a leftover. 3 went into 12 evenly, so there was no remainder for the y's. No y stayed inside. Remainder 2, x squared. That's it. There's our answer. Pause the video here. Go ahead and simplify the radical. Keep in mind we're talking about a fourth root. So we're looking at a list of powers of 4 for how we might break down the 48. So break down the 48, I think we're looking for 16. 16 is in that list of 4 powers. So 16 times 3. So the fourth root of 16 is 2. 3 is left over. 4 went into 8 twice. 4 went into 2, it didn't. So no y is coming out. 4 went into 15 3 times. Make sure there's separation here, so clearly put the index in the notch. Don't let it come out here so that we might think it's z to the 34th power. Be very careful on your writing. 4 went into 8 evenly, so no x's stayed behind. It didn't go in, so all the y's stayed behind. 4 went into 15, 3 with a remainder of 3, so z to the 3rd stayed behind. Example number 3, multiply or square an expression that's got the two radicals. Once again, because it's subtraction, we're not allowed to just distribute. We have to actually do the squaring, which means to multiply by itself. So now let's do the distributing. Multiply there. 15 minus root 45 minus root 45 plus, negative times negative is plus, root 9, which is 3. Square root of 3 times square root of 3 is 3. So we've got some like terms. We've got the 15 plus 3, those combined. This is negative 1 root 45. Another negative 1 root 45 makes negative 2 root 45. We can simplify that one, right? So break it down. We're talking about square roots, perfect squares. So root 9 root 5. Square root of 9 is 3, multiplied by the 2 that's already out there. We get 18 minus 6 root 5. Can't subtract those, because that doesn't have a root 5. This one does, so that's as far as we can go. All right, go ahead and pause here as you square that binomial. So once again, we're going to write it out, multiply it out. We get x plus 5 root x plus 5 root x plus 25. And the 5 root x and the other 5 root x make 10 root x. So final answer, x plus 10 root x plus 25. And example number 4. We've got a fraction, we've got a radical on the bottom, and it's a binomial on the bottom. And that's kind of the key part. So we definitely need to fix, because we've got the root on the bottom, but it's also a binomial. So whenever it's two terms on the bottom and we're trying to fix a denominator, we want to use the idea of conjugate. We've seen it before in complex numbers. It applies to roots as well. So the conjugate is this, but change the sign of the last part. So I'm still going to say positive 2. This is going to change to positive root 3. That's what we're going to multiply top and bottom. The password is conjugate. So multiply top and bottom by 2 plus root 3, top and bottom. Remember that acts as if it's in parentheses. So when we do the multiplication, we'll distribute the 2. Then when we multiply here, because it's a conjugate, the outside and the inside should cancel. So we should just be getting left with 2 times 2 is 4. Negative times positive is negative. Root 3 times root 3 is 3. So 4 plus 2 root 3 over 4 minus 3. 4 minus 3 is 1. So dividing by 1 means we don't need to show that. Dividing by 1 means you get itself. So it doesn't need to be a fraction. There is the answer. Again, the key, fixing this, conjugate. All right, go ahead and pause here as you simplify this expression. All right, same key, conjugate. Multiply by 2 root 7 minus root 3, top and bottom. We'll distribute there. On the bottom, we got 2 times 2 is 4. Root 7 times root 7 is 7. 4 times 7 is 28. Positive times negative is negative. Root 3 times root 3 is 3. So on the bottom, 28 minus 3 Because remember, outside and inside, they're going to cancel because we did conjugate. Distribute on the top. Combine like terms. Now we need to reduce. Okay? The number in front, the coefficients, the number on the bottom, anything that goes into all of them. It has to be all of it. We can divide them all by 5. So divide by 5 there, there, there. Final answer, fully simplified. That's it for today. See you next time.